Today we're going to cover Chapter 1, Section 1 on points, lines, and planes. So today we're going to cover some basic definitions, and the first one is we're really going to cover what the idea or definition of a point is. A point is a single dot. It is known as the simplest figure in geometry. We identify each point by a capital letter. So this point right here is point A. This point here is point B. If I was to write a third point, it would be point C, point D, and so forth, okay? I would never, like this, let's say this fifth point here, I can't name it A or B or C or D because those points are already taken. You can only have one unique name for each unique point. So that would have to get another letter. Every geometric shape that we're going to talk about, or figure that we're going to talk about this year, is really a series of points, an infinite number of points. So the points is kind of like the foundation for geometry. Notice that if I take a point and another point and another point and another point, and if I continue to do that, notice that I make a line segment. I can even take points and I can make shapes with those points. Notice that now I made a square. Now it looks like a square with gaps, but if I keep putting dots in between, points in between all these points, every shape is really an infinite set of points that creates it. And so, again, it's the foundation for much of what we're going to do. A line. Now, when you think of a traditional line, what comes to your mind is something other than this line. If I were to tell you, hey, draw a line on a piece of paper, you would draw a line that would look like that. And your line would have a starting point, and your line would probably have an end point. And we've always referred to this as a line, but in reality, this is called a line segment. In other words, it starts and stops at A or B or whatever the endpoints are. We'll talk about that. But when we're talking about a true line, okay, a true line is a geometric figure that contains at least 2 points, but it extends in 2 directions without end. It is infinite. So we'll have point A and we have point B, and a line is this infinite line consisting of an infinite number of points, really. But this line goes through this and goes on forever. So A and B are not the endpoints of the line. They just happen to be 2 points that lie on this infinite line. So you want to recognize that when you see the word line, you're talking about the one with the arrowheads that is infinite, okay? Not the traditional one that you're thinking of, the segment which starts and stops. How do we name a line? Well, we can name it with a lowercase cursive letter, so this would be line L. We could also use the word line, and we could call this line AB. Basically, you use 2 points that the line goes through, okay? Or if you don't want to use words at all, what you're going to do is you're going to pick 2 points that the line travels through, and you're going to do this bar up top, but you're going to have the arrowheads to show that it goes in both directions infinitely. Order does not matter. So I could do line AB or line BA, and that's how I would label these. So there's 4 different ways to label a line. If I happen to have an extra point in here, like point C, well, this could then be, I could do line AC, I could name it CB, I could name it BC, I could name it CA, I could name it whatever. So as long as I have 2 points, it doesn't matter which 2, and it doesn't matter the order. I just list 2, and I make sure that I have the arrowhead, okay? The arrowheads. Now, this slide, which talks about a plane, is a little bit trickier, okay? What happens is, in a plane, it's a little bit harder concept to understand. Now, when we draw a plane, okay, we always draw it as being like a parallelogram or being like a rectangle, okay? However, one thing you have to recognize is a plane is just like a line. It goes on to infinity. So it really doesn't have edges. It really doesn't have this right edge. It just goes on forever this way. It really doesn't have this left edge. It goes to the left forever, and up and down. Obviously, we have to give it edges on a paper to make it make sense, But in the real world, a plane extends in all directions infinitely. So the best way to, like, real world thing that might give you an idea, that would give you an idea of what like a plane might look like, or might be in the real world, is maybe think of your desktop, that flat rectangular surface of your desktop, or think of the floor as a plane, or a wall as a plane, a tabletop, even a piece of paper. You know, look at a piece of paper. The paper could be a plane. Again, remembering that it would extend in all directions and wouldn't have the edges. It has no dimension, no thickness. It's two-dimensional. It has a length, has a width, or a base and a height, kind of like it, when you draw it, but really it just extends. It doesn't have that depth. Although it has no edges, it would show you, again, even though it has no edges, when you see it presented on paper or on an assessment, we're obviously going to have to give it edges. Now, how do you name a plane? Well, there's two ways you can name it. You can either name it with a capital letter, a single capital letter, and that capital letter, if it names the plane, it's always going to be in one of the corners. Sometimes they even do it in script. So they might do a large capital script M, okay? The other way, so once you see that, then you can name it as plane M. Now, not all planes are labeled. Sometimes you just have a plane that will have a series of points within it. You'll have point A, point B, and point C. So if it doesn't have a plane name in the corner, you can name it using 3 of the points inside of it. You can name it with 3 or more points, but we always just do 3. So this could be plane ABC, or plane CBA, or plane CAB. The order of those points is irrelevant. Okay, you're just going to use 3. And that's it. So again, just right now, just kind of recognize how to do everything, like the syntax of everything. So for points, we've got a capital letter. For planes, again, plane names are capital letters in the corner, or you can name it with 3 points. Lines you name with 2 points. And order doesn't matter in the lines, order doesn't matter in planes. Okay, now we're going to go to some basic definitions here. We've got space is the set of all points. Collinear, co means together or on the same, so collinear means on the same line. Okay, so collinear points happen to be on the same line. An example would be point D, point E, and point F. They are collinear because they're on the same line. Non-collinear is not on the same line, and that would be something like if I added here point A. Notice that point A is not on the line above. It's not collinear with D, E, F. Coplanar, again, means points that are on the same plane. So if you look at this one up here, D, E, and F, those points are on the same plane. And non-coplanar are points that are not on the same plane. Here's where we talk about the segments that I mentioned initially. So segments, we call this line segments. And so the line segment AB, or segment AB, consists of endpoints A and B and all the points on line A and B that are between points A and point B. So what this means, when we're talking about segment, we're really talking about a piece of an infinite line. So whenever you would draw a line in school and you'd come in and you'd kind of draw your line and you'd say, okay, here's my line. It had a start, in this case endpoint A. It had an end, endpoint B. And this was a line segment. It was a piece or a segment of an infinite line. You can just say segment. You don't have to say the word line segment. And what happens is that really, if you think about it, AB, you could have this infinite line here. Okay, that's a line, yet segment, let me just kind of extend it. Let me do it in a different color. So line AB goes to infinity. Segment AB is all the points that start at A and end at B. So there's an infinite number of points in here that are going to be between those two endpoints. Okay, so because it's not all the points of the infinite line, we call it a segment, and then the segment contains some of the points that are on the line. And pay attention to how we write that. Notice that we do the same capital letters. Again, you could do BA as well, but you're going to do a bar at the top. And notice that the bar doesn't have the arrowheads because, again, it doesn't go on to infinity. It kind of starts and it stops. So this and this are two completely different things, even though they have similarities, but they represent two different parts of this line. And the last thing we're going to talk about is raise. And raise can be a little bit tricky because raise is the first time that we talk about something where order matters. So array is made up of a starting point, right? And then it continues infinitely to one side. So for example, in this example here, this first one, we start at point A and we go infinitely to the right. And notice that we go through point B. So how we write that is we do AB and we do the raise symbol at the top. Now we have to start with A because in array, the first point is the point you start at and the second point is the point you go through. And that helps to show you the direction in which your ray travels once you know what point it goes through. So when I go to this other one here on the bottom, notice that I'm starting at point B and I'm going through point A. So it starts at B, goes through A, and that's how I would draw it. And that's how I would write it. So where it starts and the direction matters. So for example, if I have here point C, I have point D, and I have point E, and I have point F. I could have several rays here, but notice I could do like, let's say C through D. That's very specific. I could do point C through E. That's also very specific. And I can do C through F. And that's specific. And notice that while they start at the same point, point C, the points they go through really determine the direction in which my ray travels. And so it really matters to be specific. So even though we say point C is the starting point, it doesn't matter here if something is a starting point or an end point. The last point, we call them all end points. So point C is your end point, and then the point it goes through must be listed next. So opposite rays happen to be rays that share an end point. Like here, point C is the end point, and they go in opposite directions. So notice that it starts at C and goes through B. That's one ray, okay? And then the other ray starts at C and goes through A, and that's the other ray. And notice that they're opposite. So you can have rays that share an endpoint and they can actually go in opposite directions. And when you have two rays that go in opposite directions, what you end up having is a straight line. It forms a straight line. Notice that really this whole thing here is a straight line. The last thing we're going to talk about before we go to our practice problems are intersections. And intersections can be in different forms. So for example, intersection is where two figures or shapes or whatever meet. They can either meet at this location or they can cross through each other or cut through each other at that location. So the intersection of two figures is the set of points that are in both. Now sometimes you might only have one point that is shared. Other times you may have multiple points that are shared at that intersection. And the last thing before we look at this drawing is to understand that when you see dashes in a drawing in geometry, what it's trying to show you are parts that are in the back or hidden from view. So if you notice these two planes in this picture, notice the dash lines there and there. That's just telling you that this, for example, this side is really behind plane B. That's up here. Okay, you really wouldn't be able to see that with the naked eye if you were looking at this, okay? And notice you have a similar thing with the line. What's happening is a line, let's say line PQ. Line PQ is laying on plane A, okay? but you're noticing that the dashed part falls behind plane B, that it's kind of blocking it. It also is kind of showing you that that line is crossing through plane P, or plane B. So again, things to look at when you're looking at these images. And then we're going to start just answering some questions. So not every time that we give you a question are we going to give you the diagram that follows it. So you may have to draw these things out yourself to identify the correct answers. So here it says line PF. First of all, let me draw line PF. A line is infinite, and that means that it goes through point P and through point F. So it says line PF ends at point P. That's false. It doesn't have an end. It's a line. A line goes on to infinity. If this was a line segment, then yes, one of its ends would be P. The other end would be F. However, it's not a line segment. It's a line, and a line has no end. Point S, so point S here, is on an infinite number of lines. Well, can I draw an infinite number of lines through S? And the answer is yes. I can sit here all day long and draw lines that go through point S. So yes, this is true. A plane has no thickness, and that is correct. A plane is 2D, and so that is a true fact. Collinear points are coplanar. So if I happen to have 3 points that lie on a line, are these 3 points on the same plane? And the answer is yes. Any points that lie on the same line are going to fall on a same plane. So this is true. Planes have edges. Yes, they have edges on paper, but in the real world, they actually do not have edges. And so this is false. They do not have edges. They go on to infinity just like a line does. 2 planes intersect in a line segment. And that's an interesting one because initially it does appear that they intersect in line segments. If I was to take the picture from the previous slide and look at it here, I see that plane B and plane A intersect. And I would think, well, wait, it ends here and it ends here, so it intersects in a line segment. However, remember that a plane goes on to infinity, which means that its intersection point would also have to be infinite. So it intersects in a line, not a line segment. And so this part here is false. Okay. 2 intersecting lines meet in exactly 1 point. And again, you'd have to draw this out, right? So you're going to come over to here and you're like, okay, here's one line, here's another line. And notice that, yes, it meets at 1 point. And so that's true. Points have no size. That is also true. And line XY can be denoted as XY or YX. Yes, the order of the letters doesn't matter, and the arrowheads are perfect there. And so this is a true statement. And now we're going to get to example 2, where we give you some problems that actually have a drawing that goes with it. Okay, now when you get to these drawings, first of all, there is a correction here, so you want to make that correction. Notice that this plane here, okay, has this N here in the corner. This is the plane name. Down here, it also has this capital P, and you're like, wait, why isn't it plane P? Well, because what's missing here is a point that we were supposed to put on. So this was supposed to be point P, this is point A, this is point X, and this is point Y, okay? And then we have plane M here, we have plane N, and we have line B, okay? So now that I've kind of, we've written out what things are, and it's probably not a bad thing for you to do as well for yourself, now I think you can answer the questions. So it says P is in M. So again, P refers to a point. So point P is in plane M. And when I look, I see that that's false, okay? Point P is actually in plane N. When I go to the second problem, B, well, I know this refers to the line, is in plane M. So line B is in plane M, and yes, that is true. When I go to the third one, line yx contains point P. So line yx would be this infinite line that would go all the way through it, and it's asking me if that line contains point P, and it does not. So this is a false statement. When I go to number 4, I know it's saying that plane M contains line yx, and that is true. Okay. When I go to A is number 5, point A is on line B, and yes, that is true. Okay, it is on the line. When I go to number 6, points, so this is point A and point P are in plane M. So A and P are in plane M, and that is false. Okay, they are actually on plane N. And then the last one, plane N contains point P, and that is true. Okay, and this one over here, this would be point A and line B. So again, it helps you at first to understand, are we talking about a point, a line, or a plane? And it helps to understand what the drawing is telling me. And that's it for today. So again, pay attention to your capital letters, pay attention to your cursive letters, pay attention to the proper way of writing things, because that's really, really important. Okay, so when we're moving forward, we know again, lines, arrowheads, line segment, or just segment, we represent it by that. We know that we represent array by that symbol. Okay, and so again, when you're writing it, you want to make sure that you use the correct symbols.